Welcome to our channel. My name is Chansi Naga Industry, and in this video we are going to discuss about our project. My teammates are Rishi, Apurva, Hemant and Alekia, and we are monitored by Dr. Hiran Kumar sir from Bennett University. This internship is offered by leadingindia.ai, which is India's largest nationwide academical and research initiative for artificial intelligence and deep learning technology, and Bennett University, one of the prestigious educational institutions. We all together had a wonderful experience during this internship. We are going to briefly discuss how to stimulate a self driving car using OpenAI gym environment. So let's get into the video.
Hello everyone, I hope you all are doing well. My name is Apurva Jindal. Today me and my team members are presenting our project, Self-Driving Car in Gym Environment using Reinforcement Learning. In recent years, artificial intelligence and machine learning has become a rapidly growing field. Image recognition, voice recognition are commonly used by all of us. Most of you must have heard of AI learning to play computer games on their own. A very popular example being DeepMind. DeepMind hit the news when their AlphaGo program defeated the South Korean Go world champion in 2016. Each of these programs follow a paradigm of machine learning known as reinforcement learning. Reinforcement learning is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing the actions and seeing the results of actions. For each good action, the agent gets positive feedback, and for each bad action, there is some penalty associated with it. A self-driving car, also known as an autonomous vehicle, driverless car, or robotic car, is a vehicle that is capable of sensing its environment and moving safely with little or no human input. The key to create a self-driving car is reinforcement learning. We will be designing a simulation of self-driving car in an environment provided by OpenAI Gym, and we will use the concepts of reinforcement learning to solve this environment.
Hi everyone, I'm Alekia. In this project, we'll be designing the simulation of self-driving car in an environment provided by OpenAI Sim, and we'll use the concepts of reinforcement learning to solve the environment. The environment we are using is taxi weekly. This environment is having 500 states, 6 actions and a reward of -1 for each action and a reward of +20 for delivering the passenger and a reward of -10 for executing pickup and drop off actions illegally. Now, our problem is to make the car pick up the passenger at correct location and drop him at its destination in minimum number of moves. To solve this problem, we tried two methods. First, no reinforcement learning. Second, Q learning. In no reinforcement learning, the agent makes random actions. As a result, it is not able to pick up the passenger and drop him at its destination in minimum number of moves. In Q learning, the agent takes actions based on the Q values from Q table that are updated during the training. In this method, the agent pick up the passenger and drop him at its destination in minimum number of moves and get higher rewards. Now, my teammate Rishi will demonstrate the performance of the two methods.
Hello everyone, I am Rishi Kanjaria and I am going to demonstrate you the visual performance of the no reinforcement learning model and the visual performance of the Q learning model. We have used Google Colab platform to implement the coding, starting with the simulation of no reinforcement learning model. Here you can see that the yellow color is our agent, that is the taxi. The location highlighted with the blue color is our passenger's location, and the location highlighted with the magenta color is our destination. In this method, you can see that our agent is taking random actions at each state. As a result, it is unable to pick up the passenger from passenger's location and drop him at the destination in minimum step. So this is the simulation of no reinforcement learning. Now I'll demonstrate the simulation of the Q learning model. You can see that the agent is making smart moves. The agent is following the shortest path to reach the passenger and pick him up and drop him at the destination. As compared to no reinforcement learning model, in this method, the agent is having minimum time steps per episode and maximum reward per episode. To have more detailed information on our project and the methods we use, you can refer the blog on our project written by Apurva Jindal. The link for the same has been mentioned in the description.
Hi, I'm Hemant and I'm going to explain you the result of our experiment. This table is the comparison of both methods. You can see here that the average reward per time step is high in case of Q learning model. Again, the average time step per episode is also high for a Q-learning agent, and the average penalty per episode is 0 in case of a Q-learning agent. So we can conclude that the performance of Q-learning method is better than no reinforcement learning method. We can see here is a graphical representation of our result. The first graph is about average reward per time step. The second graph is about average penalty per episode. The third graph is about average time step per episode. The limitation of our project is that it cannot be implemented in real world, because in real world the environment has a stochasticity, and our approach to solve this virtual environment was deterministic. Thank you very much guys. I hope you enjoyed the video, and I hope you are all safe. Thank you.